Good morning, everybody. How are you? Today we'll do a nice revision about differentiation, how to find the derivatives. I know we studied this 2 months ago, but to tell you the truth, everybody forgets. You forget, I could forget some stuff that, so why don't we do some revision? All right? So this differentiation, they lie in chapters 3, 4, 5 when you look at my LMS, and you have lecture notes 3A, 3B, 4A, 4B, 5A, 5B. I wanted to focus on 5B. There are lots of examples in 5B. Solve as much as you can. Review it like we did. We did a lot, I know. But it's good to review. And I'm very interested about the basics. But before we start the review, I would like to remind you, I uploaded for you yesterday a small presentation of 4 pages about derivatives. Go for it. Each page has one question to do. Do it as fun, for homework, for yourself. And we can discuss it if you need any help. All right, ladies and gentlemen? In 2 weeks' time, so when this week finish and the next week finish, you will receive an assignment. This assignment is worth 15%. You will take it home and you have to deliver it to me on time. What is the time? When exactly? We will let you know. Okay, let's get started. As usual, I love to make a table. On the left hand side, I'm going to write the function I need or the equation I need. On the right hand side, your job is to tell me the derivative, its derivative. So if I give you f, you will give me f of x. If I give you y, you either write it for me like this, or you write it to me dy dx. Any one of those, I'm happy. This is called the first derivative. If somebody asks you to do the second derivative, or if I want to find the second or the third derivative, because the second derivative has a meaning. In real life, this function can be called displacement or distance when we evaluate. The third derivative of that, this is called velocity vector. But if you do the second derivative, it's called acceleration vector. Inshallah, you will see that in the degree of physics and many other courses. All right? Now, let's get started. Let's start with something we call it basic rule or the power rule. If I say y equals x to the power 4, what is the derivative? 4x cubed. If I tell you 3x to the power 4, it will stay 4x cubed. Where did you get the cube from? We bring the 4 down, subtract the 4, 1. It's a 3. We multiply the 3 times 4x cubed, and the answer will be 12x cubed. Remember, I'm revising. I'm not teaching from 0. Because if I'm teaching from 0, I have a different technique to do it. Because everybody's supposed to be forgot about this material. But now I'm reminding you. How about if I have something like this? Oops. We cannot differentiate if the variable in the denominator. So what do? We bring it up. The power is reversed. Don't say like this. This is funny. People will laugh at us. That's wrong. You only switch the power. If it's positive, goes up negative. If in the denominator is negative, goes up positive. Got it? So what's the derivative of that? Leave the 3, bring the 4, minus 4 minus 1. Many people will say minus 3. I got you. No. Negative 4 and negative 1. سحبت من حسابك 4 dinars and سحبت كمان dinar. It's 5. So the answer is a negative 12x to the power negative 5. You may leave it like this, but if I want the answer to be in simplest form, you've got to, مش you may, you have to keep the power positive. Remember that. Don't ask people in the exam, oh, excuse me, can I leave it negative? I will look at you like this. No, Or maybe I can tell you I don't know. So remember, don't ask anybody. Remember, it's always simple. Who remember if the power, what is this? What is this read? Square of x stands? No. This is read as square root of x. The second radical of x. Why square? Because there is a 2 here, but by default we don't put it. Remember that one? And who remember what was the answer? I told you many times, this is a very famous one. 1 over 2 times square of x. Some people say, but Mr. I don't know what to do with it. I don't remember how you do it. Well, let's take an example. Harder example. X to the power 3, and how do you read this? It's the 4th root of x cubed. And we must, now there is no rule I can remember. The best way is to put it in exponent form. How? This is a quarter times 3. So at the end, x to the power 3/4. I'm ready to differentiate. So the derivative of that is 3/4, you break it down, subtract from the power 1. And who is smart for me? What is 3/4 minus 1? Calculator. Why? Why? 3/4 minus 4 over 4. It's a negative 1 over 4. Finished. No need to use a calculator. I'm sure you're smart, but you don't want to think. You go for it. So, the simpler step, you must simplify. You must. This is in simplest form. If you wish to put it as a root, no problem. How do I read the root? It's the 4th root. The 4 here, it's outside, it's not here. There are 2 4s. One as a power, this is the root, and the other 4 is a simple 3/4. Please leave it like that. All right? So let's call this the first part of using derivatives for powers. Some people call it power rule. In general, if anybody asks, what is the rule here? If f of x equals x to the power of n and a and x, a and n are constant, and your number, and x is the variable. So if I'm looking for the derivative, since this is the variable, I bring the power down and subtract 1 from it. That's why people call it power rule. Check up your notes, chapter 3a and chapter 3b. All right? Done. Now, we have another variety of other questions in the way, such as, actually, I'm not done. For example, I need to clean the rule here. I want to give you what comes in my mind about that rule. For example, y equals ax squared. What am I looking for? If I'm looking for dy dx, so I need to find the derivative of y with respect to x. The a is a constant. Stays. But the x squared, you bring it down. So it's simpler. Got it? On the contrary, if I ask you dy dA, who's the variable here? I differentiate with respect to x. Now I'm going to differentiate with respect to a. You gotta watch out. These are our tricky questions. Your variable is the a. So your constant at this level is an x. So you may see it this way. Some people write it this way, because they like to put the variable after. In mathematics, that's a good notation. You write the constant followed by the variable. So, since this is a constant, and since the power is 1, the answer is a. Or x squared. Yalla, give me which one? Correct. The answer is x squared. Why? Because the a is a constant. So if I have a question like this, 2a, 2x, you will say dy dx is a 2. If I say y equals 2a, if I'm looking for dy dA, you will say 2. Well, if I have y equals aw, and I'm asking you, what is dy dw? My variable is w, so I need to differentiate y with respect to w. So the a is a constant. Since the power of w is 1, it will stay a. But suppose the power was 5. Leave the a, and the power rule says what? Bring the 5 down, and this is 4. You can rewrite as a final answer 5a w to the power 4. So the w is the variable. All right, I think I can give you a huge example, but please look at your notes. I can put square root of 3, I can put square root of e. Remember, the last reminder, if you have x squared, it's different when you have e squared. If you have square root of x, it's different when you have square root of e. And if you have pi, you have to differentiate. Where is the variable? Where is the constant? If I say dy dx, the variables on left hand side the y, and on the right hand side is an x. So the derivative of x squared is a 2x. This is now, it's a constant. It doesn't matter power 2 or 12. It doesn't matter. 0. And who remember what is the derivative of square root of x? We memorize this. 1 over 2 square root of x, because we derived it in the class before. And it's another 2 constant. 0. So these are 0. Don't cross them there. Just don't write anything here. So the final answer, ladies and gentlemen, is this. All right? I think 10 minutes is enough for such a revision. What is the next thing? The next thing is the rest of the basic function we learned in Math 1. What the things we learned in Math 1? We learned how to differentiate e to the power 5x squared. Let's mix them with some chain rule, because we took them. So the derivative of that is the same. Always remember, always the same. But the derivative of the power is a 10x. You can leave it like this, you get perfect mark. Or, if you don't only worry about marks, you look about neatness, write this one in this form. Got it? Now, let me ask you this. What is this, the derivative of e to the power square of x? Let's use the power rule, guys. You know it. So, oops. I opened the pen. Lucky me, it did not go on my clothes, because that's the only clothes I have in Kuwait, in Amman. All the clothes are in Kuwait. Thank you. The derivative of this, I said, is the same. And the derivative square of x. Oh, we remember that. 1 over 2 square root of x. And guess what, my dear teacher? I don't want to finish it. I'm happy like this. I want to keep it like this. It's okay. You are smart, but you want to play games. Leave it. Now let's go to number 3. What is the derivative of ln 6x minus 3? The derivative of ln is simple and straightforward. Nobody needs to make any funny stuff. Simply, you take whatever inside the bracket and put it down. All the time. Don't say 1 over. Put it in the denominator. And the derivative of the denominator, 6x is a 6, minus 3 is a 0. Finished. And don't say, 6 with 6. No, because this will stop me. Smart guys. All right? How about number 4? Let's deal with some trigonometric functions. If I ask you, fx equals sine 3x minus 2. What is the derivative of that? Derivative of sine is always what? Good guys, it's always cosine. What's the angle? 3. No, x. No, Habibi, no. The angle is whatever between the bracket. Remember that. This is the angle, 3x minus 2. But, listen to this trick. No bracket. How do you read this? Sine 3x minus 2. So what is the angle? 3x. So don't mix up. These are our lovely questions. It is just simple thing. But what is the derivative of the angle? Like this one. What is the derivative of the power? What is the derivative of the power? What is the denominator? What is the derivative of the angle? The derivative of the angle 3x3 and minus 2, 0. So the derivative of sine is cosine. I'm not going to show you rules because the rules are in your lecture notes, in your notes, in the summary of your book. They are all there. You're smarter than this, right? You don't need it. So, how about, I'm sorry, I give you f, I should put here f of x. Because if anybody did opposite, even you wrote, I will not accept. How about if I say 2 cosine 3 negative x? Quick question, what is the angle? Exactly, 2 minus x. So the angle stays. عجبك ولا ما عجبك انت حر. The angle never touch. I like it. What is the derivative of cosine? Minus sine. Minus sine of the angle. What is the derivative? Oh, I'm sorry, sir. You have 2 here. Okay. Don't touch the 2. It's a constant. Don't think of it like a product rule, please. What is the derivative of the angle? Come. 3 is 0. Minus 1x is a negative 1. So remember, that's tricky. Let's simplify it. Negative 2 by negative 1 is what? Is a 2. The angle could be in degrees or could be in radians. It's a function of that one. So it depends where you go. One more we talked about, and we derived it in class, if you remember. Tangent. Oh my God, yes? X over pi. What is the angle? X over pi. Should I put it in bracket? Well, you can put it in bracket. I don't care. As far as you know how to see it. The derivative of this, if you remember, I'm not going to do it now because it's not our scope. Our scope is to revise. You should remember it by heart. Don't tell me, you will give me the rules in the exam. No. We give the rules of something complicated. This is your ABC for the course. If you don't know ABC, you could get an F, you could get a C minus or a B plus. So if you want to get above C, please, these are basics. You should know the rules. Practice them at home. Now, I'm not going to use the quotient rule for this, but the derivative of tangent is a secant square of the angle. What is the angle? X over pi. Anybody knows how can I rewrite x over pi? Ladies and gentlemen, x over pi, it's written as 1 pi times x. Like 3x. This is 3 times x. These are the same order. The coefficient of x is a 3. The coefficient of x over pi is 1 over pi. So remember how you see it. Why did I teach this? Because the derivative of that is 1 over pi. All right? So what I did so far, you have all the basics you need for this course. Okay? Today I did something nice. I thought it's ugly, it's bad. I chat with the student, only chatting, first talking orally. I was telling them, what's the derivative of x? They said, okay, 1. What's the derivative of x squared? They said 2x. Then I said, okay, e to the power something. They couldn't see it. So I have to write it. In the computer, we write it like this. Because this means e to the power 2x. Some softwares are not prepared other than this. But when we type exams, we can use math equation. Now let's mix these together. Let's make them higher level. All right? I will tell you what I mean. Okay. We've been 20 minutes. Let's try to push it another 10 or 15 minutes. All right? Let's call now. We call them 1, 2, 3, 4. Let's call them now number A. Question A. A, B, C, D. Am I good in that? A, B, C, D, E, F, G. Oh, it's enough. Enough. I'm good with that. Let's put some examples and mix these things together. Don't forget, these examples will follow chain rule. In your book, it's called function of a function. All right? And we talked about it a lot. We have the rules, we have the lecture notes, blah, blah, blah. But now I want to make sure that you know how to think. So let's start with something simple. Sine of e to the power 3x. This is the angle. What is the angle? It's whatever inside the bracket. What's inside the bracket? E to the power 3x. That's the angle. Of who? Of the sine. I know the angle is a variable, but that's what you have to do. So we got here like function of a function. Chain rule. Like the chain you put here. I can put 5 things together. But this is not the object. Alright, though. What's the derivative of that? We all know the derivative of sine is cosine. And the angle is, if the angle was 2x, you would say 2. If the angle was square root of x, you would say 1 over square root 2 square root of x. But if the angle e to the power 3x, what's the derivative of the exponential function? It's itself, and the derivative of that is a 3. Can I leave it like that? If you want to get perfect mark, I'm sure, but you can write it like this. 3e 3 to the power x times cosine e to the power 3x. Now you are cute. Do you see it? You don't like it? Why don't I give you another one? See if you put things together. H of x. It's 3 tangent. What should I put inside here? What things you don't like? Okay. E to the power 5x squared minus 3. The stars, he's getting tough. He wants to do things very hard. No, I'm trying to mix between chapter 3 and chapter 5. Chapter 3 are all the basics. Chapter 4 is a product rule. Chapter 5, quotient with the chain. You end up by saying everything is chain. So, ladies and gentlemen, if I'm looking for the derivative of that, who wrote this by mistake? What is the derivative of tangent? Exactly, secant squared. Don't touch the angle. What is the derivative of the function inside? Oh, e to the power itself. What is the derivative of the power? Oh, 10x minus 0. That's what we call it, Mr. Chain. We did it a long time ago. It still keep coming the same and the same. How about this one? This is for your eyes only, ladies and gentlemen. Len of 2 cosine 3x. So if I'm looking for the derivative, that's simple. The derivative of that, oh, Len, whatever between the bracket, it goes down. Very beautiful. What's the angle of the cosine? 3x. What's the derivative of cosine? Actually, what's the derivative of the denominator? So this is called denominator. Take its derivative. Put in numerator. Take it down up. So what's the derivative of 2 cosine? 2 stay the same. The cosine is minus sine. Don't touch the angle. Angle, angle, angle. Don't touch. But what's the derivative of the angle? Oh my God, it's a 3. That's chain rule. Who remembers sine over cosine equals what? Anybody? Sine over cosine is tangent. Whatever the angle. Is the sine and the cosine have the same angle? Yes. So the angle is, what's 2 over 2? Bye-bye. What's left? 3 times minus. So the final answer, negative 3 tangent 3x. All right? And that's the beauty of chain rule. You think systematically. Number D. Ready? Let me give you something. Y equals 3x squared times sine 2x. This is different from, ladies and gentlemen, different from 2 sine 2x. Because that's a function time a constant. That's called single function. In here, we are having 2 multiplied function. Here we have the product of this and that. So who remember how do we do the product rule? The product rule. Look at this sum. Derivative the first time the second plus derivative the second time the first. If your teacher do it differently, it's okay because it's a plus. So what is derivative of the first? Times the second. Don't touch it. Plus, what is derivative of sine? Cosine 2x. Derivative 2x, 2. All right? Times what? Times the first. What is the first? 3x squared. So, ladies and gentlemen, if I tell you this is u, this is v, derivative of the first times the second, plus derivative of the second times the first. We won't give you the rule because you get to use that. All right? You remember that one now? You want to take it down? Take a note. You want me to get out of your way? Harder. I'm sorry, but like I've told you, this will be a nice revision for the weekend. What comes after D? F or E? F. Okay. How about if I give you this? Y equals you can never simplify that. Only if it was like this. This with that, take it up, blah, blah, but you can't. So, even if you want to move it into product rule, it's ugly. So here, we are having 2 parts are not related. This is the numerator, I'm going to say, let's call it U. This is the denominator. So what's the rule for that? The rule for this, derivative of the first times the second, minus derivative of the second times the first. And the denominator squared. Let's put it together and see if we can do it. What's the derivative of the first? What is the derivative of the denominator or the second? No, we don't take derivative. We just keep it like that. So derivative of the top times the bottom minus derivative of the bottom times the top. Some people cannot see it, they need the white one. Derivative of the top times the denominator minus derivative of the denominator times the top itself. What do we do down here? We do something called v squared. So what is v squared? We take all of this and then you square it. All right? Now we have half an hour finished. Why don't I give you the last 5 minutes, couple of questions. I love them.